Hi everyone. So in today's lesson we're going to look at how you would represent negative whole numbers in binary. We're going to use a system called 2's complement to convert the negative whole number into 8-bit binary. So the first example I'm going to show you is how you would represent negative 77 using 2's complement. So you first of all take it as positive 77. So you say 77 bigger than 128, nope. Smaller, put 0. Is it bigger than 64? Yes, put a 1. That leaves you 13. Is 13 bigger or smaller than 32? Smaller, put a 0. Is 13 bigger or smaller than 16? Smaller, put a 0. Is 13 bigger than 8? Yes, put a 1. That leaves you 5. Is 5 bigger or smaller than 4? It's bigger, so put a 1. Take 4 away, that leaves you 1. Is 1 bigger or smaller than 2? Smaller, put a 0. And it's 1 equals 1. So if you add up 64, 8, 4 and 1, does that give you 72, 76? That gives you 77. The next thing you do is you invert it. So every place you've got a 0, you make it a 1, and every time you've got a 1, you make it a 0. So first one was a 0, so I'll invert it to make it a 1. Second one was a 1, I'll make it a 0. Next one was a 0, make it a 1. Next one was a 0, make it a 1. Next one was a 1, make it a 0. Next one was a 1, make it a 0. Next one was a 0, make it a 1. Next one was a 1, make it a 0. And the final thing you do is you add on 1 to the end number. So it would just be 1, 0, 1, 1, 0, 1, 0, 1, and then I'd add this one on. So it would just be your answer would be 1, 0, 1, 1, 0, 0, 1, 1. And that'd be our final answer. So negative 77 would be that number using 2's complement. Okay. Now it's easy when it's an odd number. When it becomes an even negative number, it's a bit more difficult, and I'll show you why. So could you do negative 121? Put the answer in there. Negative 155 and negative 47. So they're all odd numbers. And I'm going to show you how you do an even number. So this time we're going to do negative 66. So bigger or smaller than 128, smaller, put a 0. Bigger or smaller than 64, put a 1. That leaves you 2. So it'll just be this. So if you add them together, that's my 66. I then invert. So every 0 becomes a 1, and every 1 becomes a 0. Now, you can see at the end here it's difficult because you've got to add on your 1, but adding 1 on 1 obviously it can be 2 because you're doing it in binary. So what you would do is you'd add 1 plus 1 would give you a 0, so you'd put a 0 in here, and you would carry the 1. So 1 plus 1 is 0, carry the 1. 1 plus 0 is 1. So the 1 would move along a wee bit, and the rest of the numbers would just be the same. Okay, so negative 66 in 2's complement would be 1, 0, 1, 1, 1, 1, 1, 0. So what I want you to do is, you've got 3 more questions under here. They're all even numbers. So negative 72, negative 88, and negative 120. So if you can try them. And the final wee thing is, sometimes you're actually given the binary number and you're asked, using 2's complement, convert it to a negative. That should be negative decimal number. A negative decimal number, right? So these are the kind of questions you might get. Using 2's complement, convert 1100, 1110 to decimal. So what you would do is you'd lay it out. 1100, 1110. Okay, and you would invert them. So you would, every 1 would become a 0, so, and every 0 would become a 1. And then I would do what I kind of did in the last task. So 1 plus 1 is 0. Carry the 1. 1 plus 0 is 1. and the rest of these will just be the same. And then what you would do is, because we're trying to get the decimal number, you would add up every time there's a 1. So you'd add up 32. So it'd be 32 plus 16 plus 2. So is that right? 32, 16 and 2. So 48, 50 would be the answer. Now, if folk would dive in and write 50, that would actually be wrong. The answer is negative 50. Okay, so what I'd like you to do is, I'd like you to do the last 3. So convert the number in pink to decimal for the last 3 tasks. So this exercise is out of 9, everyone. So see how you go on representing negative whole numbers using 2's complement. Okay. Also, enjoy the long weekend and take care. I'll speak to you next week.